Now the continued session is about finding the remainder when a polynomial is divided by another polynomial. So this session will discuss about how we can find the quotient and the remainder for the polynomials which are divided with each other. To start with, finding the remainder. Let's take some example polynomials for understanding this concept more better. For example, I have a polynomial p of x, which is x cubed plus 3x squared plus 3x plus 1, which is divided by another polynomial x plus 1. And I would like to find the quotient and the remainder for this polynomial p of x being divided by another polynomial x plus 1. As we know that the long division method for dividing the polynomials is with the dividend taken in the middle, x cubed plus 3x squared plus 3x plus 1, and the divisor which is taken on the left is how we start with the construction process. Now continuing with this, I have x cubed which can be filled up by multiplying x with x squared, so that I get x times of x squared, which is x cubed, and 1 times of x squared, which is x squared. And then I subtract with the change of signs, this get cancelled, and I get this to be 3x squared minus x squared is 2x squared, with the other two terms drop down directly from the given expression. Continuing in the same process, I have 2x squared which can be satisfied by multiplying x with 2x. So the quotient gets added up with 2x, which when multiplied with x gives me 2x squared plus 2x. And then on further subtraction in the same process gives me with change of sign 2x squared and 2x squared getting cancelled, and 3x minus 2x is x plus 1. So finally, this is the term where I end up because I don't have any other term, or I can take plus 1, so that 1 times of x is x and 1 times of 1 is 1, which on further subtraction gives me the change of signs and then cancel to give me the final answer as 0. So with the end of this, I understand that this is my q of x and this is my r of x. Is how we identify the remainder and the quotient for the given polynomials divided with each other. The long division method is what we call this. Therefore, for the given polynomial p of x equals x cubed plus 3x squared plus 3x plus 1, when divided with the other polynomial x plus 1, I get my quotient q of x is x squared plus 2x plus 1, and I get my remainder r of x is 0. Is how we understand the process of finding the remainder or the quotient using the long division method. Now that we have discussed about division of two polynomials f of x by g of x, it's very important that we just divide a polynomial with the other polynomial through a condition. Let's see what the condition for divisibility of two polynomials is out here, along with the division method of dividing the polynomials as we have seen in the previous session. Condition for divisibility of polynomials. Condition for divisibility of polynomials. Let's see how the condition exists for two polynomials being divided. So for example, I have a polynomial f of x which is divided by another polynomial, say g of x. Then the divisibility condition says that this polynomial can be divided by this polynomial provided we have degree of f of x is greater than degree of g of x, is how I see the condition for existence of divisibility of two polynomials, is how I see the condition. Condition for divisibility of two polynomials is only possible when degree of f of x is greater than degree of g of x. For example, if I take a polynomial 2x cubed plus 5x minus 2 by x power 7 minus 4, then clearly I see that the degree of this polynomial in the numerator is 3 and the degree of the polynomial in the denominator is 7. Therefore, I don't have my condition which satisfies here, because clearly in this case degree of the numerator is less than degree of the denominator, in this case 3 less than 7. Therefore, f of x cannot be divided with the polynomial g of x in this case of the example problem. F of x can be divided with the polynomial g of x only when degree of f of x is greater than degree of g of x, and the division is done through the long division method as discussed in the session.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.